Okay, so we're going to be looking at section 5.4, which is going to deal with adding and subtracting polynomials. And like we do with most things, or most sections, we need to lay out some terminology first before we really jump into adding and subtracting polynomials. So the first part of this section is going to be a lot of terminology, kind of basics that you need to know really before you can get into the adding and subtracting. The adding and subtracting part of this is not difficult, but we got to get there first. Okay, so some of this stuff you're going to have seen before, some of it may be new to you. We're going to start with the idea of combining like terms. This is something that you have done for a while. When we solved equations, you combine like terms. When we simplified expressions, you combine like terms. What is different about this section, though, is that we now have multiple variables, and those variables may have exponents. And so before we can try to add or subtract polynomials, we have to understand what it means to combine like terms. And so some examples of like terms you can see listed on the screen. 2xy squared and 4xy squared would be considered like terms. 19m to the fifth and 14m to the fifth are like terms. 3pq and negative 2pq are like terms. So like terms must have the same variables with the same exponents. You need to make a note somewhere in your notes about that. If you have like terms, they have to have the same variables with the same exponents. And so you can see some examples here of unlike terms too. So 7x and 7y, for example, are unlike terms because they're not the same variables. Z cubed and z squared are unlike terms. Again, same variable, different exponents. 4pq and 2p, one variable is the same but not both variables. And so in order for our terms to be like, if we're adding and subtracting, we're trying to combine like terms. And so when we combine those like terms, we have to have the same variable with the same exponents. So let's do one real quickly. So if we're going to add 5x to the fourth plus 7x to the fourth, when we're adding terms, all you do is combine the coefficient, the number in the front. In this case, the 5 and the 7 are the numbers that we're combining. That x to the fourth, we're going to treat it like it's some random thing. For example, if I said we were to take 5 chairs and we're going to add that to 7 other chairs, well, what do we have? Well, we have 12 chairs. Those chairs don't now stand up and dance. They're not magical chairs. They don't change. It's just chairs. And so if we have 5 of these x to the fourth, whatever that is, and 7 of that same thing, those same x to the fourth, when we combine them together, then we have 12 x to the fourths. And so that's how we would combine those like terms. Now, you can see the same thing in the next example. 9pq plus 3pq minus 2pq. Well, they're all pq. They all have the same variables with the same exponents. And so 9 of those plus 3 of those is 12, and then 12 minus 2 would be 10 pq. Again, the pq does not change. It is still just pq. Okay? So we're going to talk about combining like terms. It's going to be a big part of the adding and subtracting we'll get to in a little while. The next thing you need to know is what a polynomial is. And I'm not going to give you a big, long, wordy definition of what a polynomial is. I'm going to show you some examples. We're going to talk about it. One of the things about a polynomial that you need to know is it is a collection of terms where numbers, letters, those letters with positive exponents. So in some of our other sections already, we've talked about negative exponents. We have to have positive exponents for it to be a polynomial. All these things are added and subtracted together, multiplied or divided together. Okay, so each term is added and subtracted. Within that term, you have some things either multiplied or divided. And so our general form is going to look like this example. Okay, the 16x to the 8th minus 7x to the 6th plus 5x to the 4th minus 3x squared plus 4. When we are writing a polynomial, we have to put our answer in descending power of exponent, or descending order of exponents or powers. Meaning we start with the biggest and work our way down. So you'll notice here we have x to the 8th, x to the 6th, x to the 4th, x squared, and then our constant term is always last. Okay, that one without a variable is always the last one. As you're working through your math lab, if you add and subtract and you get the right answer, but you didn't put it in descending order of exponents, it's going to tell you it's wrong. Okay, so make sure that you do have your answer in descending order of exponents. The only time we'll kind of disregard that is when we get to division later on. That'll be something where if you don't have the division in descending order, it's not a huge problem. Okay, so again, we'll talk more about that later on. The next thing you need to know is the degree. So finding the degree of a term, you simply add exponents. You add all of your exponents together of all the variables, and that gives you your degree. Now, when you get into college algebra, there will be a need for you to know the degree. Right now, there's not a need for you to know it or know how to, know the purpose of it. You just need to know how to find it. And so, to find the degree of a term, you're going to add the variables of the exponent. So, in this case, we have an exponent of 2, and then this y has an exponent of 1. And so when we add those 2 and 1, we get 3. The degree of that term is 3. Look at the next one. What's the degree of this one? Well, this x has an exponent of 1, and the y has an exponent of 1, and 1 plus 4 is going to be 6. And then on the next one, the 3x, the x has an understood 1, and so x to the first power, that 1 is the degree. So pretty simple, just add up those exponents and that will give you the degree of a term. Now, understand that a term is a collection of things being multiplied or divided. You may want to write that down somewhere. A term is a collection of things being multiplied or divided. That's important to understand because as we look at polynomials, we may talk about a specific term or terms, and you need to know, okay, this is a term versus that is a term. Terms are typically separated by addition and subtraction signs. Okay, so just kind of be aware of that. So when you look at the next one, the degree of a polynomial, it is the highest degree of each term. Okay, so when you look at each term, whichever one has the highest degree, that is the degree of the polynomial. So for example, in this first trinomial here, in this first term, 9m cubed, the degree is 3. For the next term, the degree is 2. For the last term, it's technically a degree of 0. And so, obviously, which number is higher? 3 is higher. 3 is the degree. Okay? Again, hopefully that makes some sense. On the next one, again, if you look at the degree of each term, the first term has a degree of 5. The next one has a degree of 2. And so, obviously, 5 is higher. That's the degree of the whole thing. Now, here's a little secret to this. If there's only one variable, the degree is the highest exponent, the largest exponent. If there's multiple variables, x and y, or whatever, m and n, or whatever the letters may be, if there's more than one variable, then you've got to do like we're talking about. Find the sum of each term add those up, and then the highest degree. But typically for the polynomials we're going to deal with, there's only going to be one variable. And so the degree is always that highest exponent. So, something else that you need to know. When we talk about these polynomials, we are talking about, in general, polynomials. But if we know a polynomial has a specific number of terms, then some of these have special names. If the polynomial only has one term, we call it a monomial. The prefix mono means one. And so a monomial is going to have one term. And you can see the example there, 4x squared. If a polynomial has two terms, it is a binomial. Prefix bi means two. And so if it's a binomial, just like a bicycle has two tires or two wheels, same thing with a binomial. There are two terms. And then if it is a trinomial, then it has three terms. Again, the prefix tri means three. And so we have a trinomial. Now, if the polynomial has more than three terms, we simply call it a polynomial. You see that word here at the top of the screen. What does the prefix poly mean? Well, hopefully you know it means many. And so if we have more than three terms, we call it a polynomial. However, you need to understand each of these could also be considered a polynomial. Even if it's a monomial where it only has one term, it still can be called a polynomial. Okay, polynomial is sort of a catch-all term for any polynomial, whether it's got one term, two terms, three terms, 10 terms. It doesn't really matter. A polynomial is a catch-all term. However, if we know specifically we're talking about a binomial, then we're going to say that. We're going to say binomial. Later on, when we talk about division, we're going to talk about dividing a polynomial by a monomial. And so when we know it's a monomial, then we will use the term monomial. But if we don't know if it could be others, binomials, trinomials, whatever, then we may refer to it as a polynomial. Okay? So be aware of that. So what I want us to do is, again, just to kind of help you identify what a polynomial is, we're going to go through and identify each of these as either a polynomial written in descending powers, or not a polynomial. And so as we look at these, I'm just going to label these as A, B, or C, depending on which one it is. And obviously you can see the screen there and see what A, B, and C are. So on the first one, is this a polynomial? That's a good place to start. If you look at this one compared to the other polynomials that you've seen so far, you would say, yeah, that looks like a polynomial. It's a collection of terms being added and subtracted. Those terms are made up of numbers and letters with positive exponents, all being either multiplied or divided. So yeah, that kind of fits that definition. And so it is a polynomial. The next question is it in descending order of powers? Well, yeah, you have a power of 5, power of 2, power of 1, and then your constant. And so this is choice B, a polynomial with descending powers. Now, go to the next one. Is this a polynomial? Well, again, it appears to fit that definition that we've mentioned. And so we would say, yeah, it is a polynomial, but is it in descending order of powers? And the answer to that is no, because it is p to the fourth and then p to the sixth. It's not in descending order from 6 to 4. And so this one is simply a polynomial. And then on the last one, the question is it a polynomial? And probably most of you would say no, and you would be right. And my question then is, well, why is it no? And the answer to that is because this x is in the bottom of the fraction, not because there's a fraction. Okay? Fractions are okay in a polynomial, but the x can't be on the bottom because, as we've talked about previously, if you were to take that x and move it to the top, well, its exponent's a 1 now.